energy on in chapter 12, which was one thing was the vector equation of the line, scalar equation of the planes, and we use those so often in the material that you guys basically get used to it. You don't have to quite review chapter 12 for that. Things that were completely new were quadric surfaces, where you saw an equation, including x, y, and z. So an equation with x and y and z at most degree is 2. What I'm going to ask you on the exam is to recognize each surface, to connect if I give you a shape, I want you to be able to tell me, match it with an equation, basically. If you look back at the past exams, I have this little trick with me. If all three, x, y, z, are in the format to the power 2, see which ones are there. One is that, the other one is that. So if they all in the equation appear with the power 2, then I know what I do is I take all three of them to one side. If I need to complete the squares, I complete the square on that side. So all variable to the right side, for example, then complete the squares if you have to. Then if I see only pluses between, I remember that's an ellipsoid. If I see that, basically, if I see that two of them are positive and another one is negative, so, and the other side is positive, then that's a hyperboloid of one sheet. And then if I see that if I take all of them in one side and in a complete squared form and I get a 0, that's a cone. If I have, again, two of them of the same sign, one is a different sign and the other side is a negative sign, then I will have hyperboloid of two sheets. What is left are the two that you see only one variable, not of power 2. And that you kind of figure out that it has to be related to parabolas. If there's a negative between, it would be hyperbolic paraboloid with the two terms with power 2 negative between. It's a hyperbolic paraboloid. Sorry, I said all the names at once. And then the other one is the elliptic paraboloid, when the two terms with the square are of the same sign. So that's my overall to remember how things work. Then there is the cylindrical and spherical coordinates and the conversions. The conversions for spherical and cylindrical are so important. What I'm going to do is on your extra credit quiz, either on Wednesday or Thursday, I'm going to ask you to complete that, basically, to match which one is which, because this one you need to kind of memorize. I'm not very big on memorization, but also you can look at how things are, as phi is the angle between the position vector of the point in Z, right? And rho is the distance of between point and origin. So you can basically draw these conversion formulas. So that's something to memorize, and it's good because you will need it later. So phi is the angle between the position vector of P and Z. So it's 0 when P is on top over here, and it gets bigger and bigger as we go toward the Z negative, basically, as we go to the which octane is it? It's octane 4. As we go toward the octane, as from octane 1, we get closer to octane 4. And so at Z, on the Z-axis, negative side of the Z-axis, phi is going to be pi. And that's the biggest value that phi can get. But what is theta? Theta is just that thing that goes round. It's very much like polar coordinates. And the other thing that you can imagine is if I find the projection of phi on P, the point P on the XY plane, this R and that theta are going to act like polar coordinates. So that was a brief explanation. Let's try to go about doing some of these things, right? So better. Everybody okay? Everybody can see everything? So now, I said that ellipsoids, cones, and hyperboloid of one sheet and hyperboloids of two sheets, these 5 have to have x, y, z all to power 2. And then if it's ellipsoid, because all the cross sections are ellipses, you basically, if you put all the variables on one side, then x squared, y squared, and z squared have to have the same sign, same SIGN. So I'm going to go back up there. There are 2 that have, do you see that all the variables on one side? And both of them are equation of an ellipsoid. So what is the difference between these two? The best bet is to basically write these as this format. Let me bring it back. So what you want to see is this format. And I'm going to write it that format. X squared plus 4y squared plus 9z squared equal to 1. In that format is going to be x squared over 1 squared plus y squared over 1 over half squared plus z squared over 1 over 3 squared equal to 1. Okay. So on the x-axis, you go the furthest. You go to 1. On the y-axis, you go to 1/2. On the z-axis, you go to 1/3. That's how it expands. The ellipsoid expands. So let's see, which one is the z-axis that the longest? That's the one, right? And so that is A. Fair enough? And so now I want to know what happens with B. That was A, and then B is 9x squared plus y squared plus z squared equal to 1. So it's x squared over 1/3 to power 2. So I'm taking it to the denominator. Therefore, I have to reciprocate, right? You have to go 1 over plus y squared over 1 plus z squared over 1 equal to 1. And this seems to be shortest on the x-axis. And so this would be B. Now, let's see which one is the cone. With cone, if I take all the variables to one side and make him into complete the squares, I should get 0 on the other side. So completed the squares, and then I should get 0 on the other side. Let's see which one of these is gonna satisfy that. Oh, look at this one. So all of the others, if I take all the variables in one side, I'm not gonna get it, and they have to be all power 2. So that is the one, basically. Again, if I want to quickly recognize the cone, that's my trick. If I take all the variables to one side, I end up with a 0. I do like to have in this format. Now, tell me, the variable that is opposite sign with the other two is y. So my cone should be lying toward, expands toward y-axis. Is that the correct one? Yes. So that's the answer. This tells me lies on the y-axis. And so F is that answer. Now, that's not the cone. F, sorry. It lies on the y-axis. Now, between the other two that have, these two have every term to power 2. So I have to decide which one is which. So if I write it as C is x squared minus y squared plus z squared equal to 1. D is negative x squared plus y squared minus z squared equal to 1. Now, if I write C only one term is different sign, it is negative sign equal to 1. D is, these two have both of the two terms with negative. So I multiply everything by a negative sign. X squared plus z squared minus y squared equal to negative 1. Now, that one is the hyperboloid of one sheet. This one is hyperboloid of 2 sheets. And so why is that true? Because imagine if I take the one with a different side to the other direction, then, and I plug in y equal to 0, then I will not have any variable, any x or z solution. And that's my clue for knowing that there is a gap in between. However you want to do it, compare these, and the one that is a different sign, for whatever complete the square is, plug in 0. So for that one, I plug in 0. If I plug in x squared plus z, plug in y equal to 0 to solve for x and z, it becomes that. And this is not, there's no solution. So there is a gap. So hyperboloid of 2 sheets. But if I do the same thing for C, you will still have a solution. And it's always a ellipse, or in this case, circle. So now I have 2 more to say. D is the hyperboloid of 2 sheets. C is the hyperboloid of 1 sheet. There are 3 more left. Notice one that is cylinder. With cylinder, you get the same cross-section in one direction for any values of y with the cylinder, right? So now all of the cross sections are the same in y direction, and they are all circles or ovals sometimes, right? Now, in this case, I think it's actually, is it a circle or is it oval? Oh, that's actually, this one is oval, according to the equation. Now, because it lies on y-axis and the cross-section are not related to y, you know that y is not going to appear in the equation. So go back and see which equation doesn't have y. That's the one, right? And so match the cross-section. Cross-section for any y is going to be an oval, matches this. So you're all okay. So that one is G. Now, what are left are the two with, do you see that y doesn't have power 2, y doesn't have power 2. But the other two variables are power 2. Okay. So when you have one of the variables just power 1, it's easy to quickly recognize, because if I put the other two variable on the other side, I can see easily there's a difference between squares. That one, there's a plus between squares. Plus between squares tells me about parabolas and the cross sections that are